Hi there. We're going to try a lab with the Vernier carts, and this lab is called the Crash Test Lab. So this video is for teachers trying to set the lab up and for students to understand what kind of data we're collecting during this lab. So we know that kinetic energy depends on two things: the mass of an object and how fast an object's going. And we already learned from our PEKE that the higher something is positioned, the more potential energy it will have, and that as an object travels down, the potential energy gets transferred into kinetic energy. Now we're going to take what we've learned about energy and kind of apply it to momentum and, in this case, a crash test. So the Vernier cart should be set up on a slant. The lab recommends to have at least 45 centimeters underneath the cart. So it's about 45 science books. And we have just one cart to use. And the crash wall is going to be this brick that is set 30 centimeters from the base of the track. So what we want to do is we want to see if there's any correlation between the speed of the car going down the track and the distance that the passenger in our car is thrown when it hits the brick. Okay, so we know that momentum depends on both mass and velocity, and that during an impact, momentum is conserved and transferred. And this brick is not going to be moving. So we have our little passenger in the car. He's got a little seat. And what we're going to do is we are going to release it from 3 different positions on the track. And this gets a little crazy because the car is going to go flying, the passenger is going to go flying. But what we're going to do is we're going to use the software to find out what was the maximum velocity that the rider experienced at the bottom of the cart. And then we're going to measure how far the passenger flies off of the cart during the crash. So he has no seat belt and no restraining device. Okay, and then we're going to do that a few times for each to get an average, and going to see is there any correlation between speed, momentum, and the distance that our passenger goes. And then if we have time, we'll talk a little bit about how seat belts and airbags work, and we can even put a little seat belt on our passenger. So I want to show you what it looks like using the Vernier graphing system. What you want to do is you want to connect one of the carts, and we want to make sure that the mode, which is the lower left hand button, is set to stop recording after 3 seconds. Okay, and we should have a position graph and a velocity graph, and we really only need to use the velocity graph. So we're going to position our guy in the cart on the track, and the lab recommends, if you have the ability to put guardrails on the side, and this really is a couple person job, so I'm going to try to do it by myself, but I'm going to click collect, and then I'm going to let go of the cart. Okay, so ideally we would be doing this on the floor. My cart went flying, my guy went flying. That wouldn't be an accurate measurement of distance, so the floor is definitely a better place to do this. But what we can see on the graph behind me is we can see the maximum velocity. So there's a couple ways you can get this. You can put the cursor right over the highest point of the graph and click on it. And this is 2.467, or you can click down here in this graphing tool and view statistics, and it tells me, I actually did a pretty good job clicking on that, 2.467. So students will be recording the velocity, so this is how fast it was going right at the end of the track, and they would also measure how far the passenger of the car flew. And then we would go on to answer those questions in the lab and see what kind of a correlation. And this is a good opportunity to talk about restraining devices in cars and why seatbelts and airbags are so important. So if you have any questions, let me know. Hopefully you have fun using the Vernier track and the Dynamics carts.